In this video, we are going to talk about the Raycaster. Raycaster is a class that's designed to actually assist with raycasting. Raycasting topic is one of the most important class inside the Three.js. Let's see examples so we can actually explain it more. So as you can see here, when our mouse hover or enter the zone of each object, each object color will be changed suddenly. As a matter of the fact, Raycaster will help us to actually calculate our mouse position, and whenever our mouse enter the object zone, it will be actually change the color. Let's see more example in the Montreal 3D.studio. So let's just add the cube here, and as you can see, another object and another object. So we have three different type of object here, and what is the Raycaster? Whenever actually the Raycaster enables us that whenever we clicked an item, it will actually add these axes, so I can move it, and we can apply this functionality by using the Raycaster. The Raycaster will actually calculate the mouse position, and after that the object is clicked, it will be applied the transfer control that we previously discussed. And as you can see here, we can now just apply our changes. So let's see how is raycasting actually is work. Whenever we actually whenever we are in 3D scene, we have actually camera perspective point. From that point, the Raycaster, when we apply the Raycaster functionality in our code, from that time, whenever actually we clicked a particle, an object, it will be actually shoot something called ray. And the ray is actually going to transparent. Is a transparent like the laser, and it will be continuously goes until the ray value is finished. And whenever it has an intersection with an object, it will be actually return the value of that object. And by having the ray and the shooting ray, we can actually just set whenever two objects are in the same ray, we need to just whenever our mouse click, just choose the first one and show the first one function transfer control. So in here, there is an example provided by Three.js documentation. First of all, actually, we need to define the Raycaster, and we need to actually define a pointer, which the data type is vector2. And there is a function called onPointerMove. Each time, whenever our mouse actually change the position, our mouse hover inside the our windows, it will be calculate the position of X and Y of the mouse, and actually normalize the XY value between -1 and 1. And as you can see here, there is a function called render, and there is a add event listener on pointer move, which whenever on change the value the on pointer move, it will be actually just calling the on pointer move functions. In the render function, we define the Raycaster from the camera view, and the input parameter is pointer and the camera. The pointer is the position of our mouse, and the camera was the initial camera value, which will be defined in our code. And in the intersection part, Raycaster going to actually insect object, and as a matter of the fact, it's going to actually it's going to return the selected item by ray. Whenever we shoot a ray, it will be actually return the value of those objects have the intersection with our ray. So, and it will be actually get the input of the scene.children. We are going to actually see what is the scene.children, and in the for loop, we are going to actually change the color of the intersected object to the another color, and as you can see here, intersect dot object dot material dot color dot set will be change the color of that specific object. And note that we may our mouse pointer may actually have the intersection with different materials in our 3D scenes. And after that, we are going to actually render these changes. And as you can see in the example provided by documentation, you can see the object color will be changed. Before actually we applying the raycasting, we need to actually see what is the scene.children and how can we actually get the different children of our scene. So I just initialize my Webpack dev server by using yarn dev, and it will be open our actually local host. So there's an object here, there's a cube here that I just coded previously, and let me see what are these different files here. So in here, there are scenes that have a multiplied children. In here, after everything happened and our controllers update, we actually going to get the console log, and in console log, we are going to set it that what is the value of the scene. The scene consisting of different objects, different camera, different light, and when we are actually going to get the console log value, it will be return an object and a JavaScript object which have which containing have a different properties. The animations, the background, the children, different layer, the matrix, and as you can see, if we have a parent element for this scene, it will be shown. However, it is null here because our scene is the parent element, and there is a children which is an array, and in here we have actually one children, and in our code there is just one place that we actually add a children, and each children typically have this information specifically and separately. You can actually see the different hierarchy that's happening here. So there's a parent scene, there's a children scene, and each children scene may have a their children. And actually, let's add different objects, and let me see that I have a code here. Yeah, this is here. So let me refresh my page. This is a code related to the textures and the shadows. We have a light, we have a two different lights, and we actually get the console log of the scene. We can see the different children of our scene. So in here we have four different children, two meshes, one point light and one directional light. We have two different meshes. So as you can see, the first children is mesh, and the mesh, and as you can see there, you can actually specify the name of the different children. We can actually set it name. In afterward, we are going to actually set the different name of our children. And as you can see here, we have two lights, and we have four different children in our scene. And as you can see here, we have a for scene.add method in our code. So let's apply the raycasting in our code, and I just copy the example provided in the documentation. First of all, we create a raycaster, the pointer, and actually in here, after calculating the mouse position, we set the raycaster set from camera. So if we have a camera movement, if we actually explore in the environment, the camera value will be updated, and we set the raycaster dot set from camera, and actually we get it. We set the pointer and camera, and after that we create a variable called intersect, and in intersect we are going to map through each children and see that if there is any intersect. In here, I changed the on pointer move in the add events listener to the clicks. So each time I click, it will be actually show the result. And as you can see here, we have one intersection, which is our object, and this is the white plane, and yeah. So afterward, if we are going to clicking on the cube, as you can see, we have two objects. The first one is the cube, and the second one is the white plane that shadow casting on it. And I just set the Mondial 3D ID to the 1 to 3. You can set it by yourself. And if we actually click outside of these objects, it will return null. And as you can see here, we have two objects. So the only things that we can do, if we are going to actually apply the transform control, we can just set the first intersect to the applying the intersect to the apply the transform control. So and as you can see here, we can actually return the cast shadow value. And as you can see, the first cast shadows, the first element that the array have the intersect will be actually return the cast shadow. Different implementation can be applied, and for the next stage, we can actually change the material. Whenever we have the intersection, we can get the actually first or maybe all the intersection object and change the material. So we created mesh standard material, and as you can see, we can intersect object dot material to be the new material.